A regular person in China just sat inside a two-seat aircraft with no pilot, no joystick, and no controls on the dashboard. They tapped a screen, picked a destination, and flew there. No license, no training, no stress. That is not science fiction. That already happened. And at the same time, in a testing facility outside Shanghai, engineers certified an engine that gets 106 miles out of a single gallon of fuel, verified and stamped by Guinness World Records. A number so far beyond what anyone expected that engineers across 3 continents went genuinely quiet when they heard it. 2 breakthroughs, both real, both happening right now, and both pointing at the same thing: the biggest shift in how humans move since the invention of the car. By the end of this video, you will see exactly why the next 10 years of transportation are going to look nothing like the last 50. Let us start with the sky. For most of human history, flying meant one thing. You needed a pilot, a license, a runway, an airport, and a ticket. The barrier between a regular person and the ability to fly was built out of regulation, training, cost, and complexity stacked on top of each other for 100 years. Nobody seriously questioned whether that barrier could come down. It was just accepted as a permanent fact of life. That fact just changed. The first vehicle on this list sounds impossible until you see it work. EHang Aero HT, a Chinese company that builds both electric cars and flying vehicles, did not try to make one machine that does everything. They asked a different question entirely. What if the car and the aircraft were 2 separate things that worked together perfectly? So they built a 6-wheeled electric truck. Spacious, tough, looks like something from a science fiction film. But hidden inside the back of that truck, folded up neatly in the cargo bay, is a fully electric 2-seat aircraft. You drive out to an open field, press a single button, and the aircraft automatically deploys from the back of the truck, unfolds itself, and prepares for launch. A few minutes later, you are in the air. This is genuinely clever thinking. Most companies trying to build a flying car end up with something that drives poorly and flies poorly because they are trying to do both at once. EHang Aero HT said, forget that. Make a great truck. Make a great aircraft. Have them work as a team. And because they are building this using the same electric motors and battery technology already running in millions of regular electric cars, the production cost stays surprisingly low. That matters enormously, because the number one thing keeping flying vehicles out of regular people's hands right now is the price tag. Drive to a scenic open field on a Saturday morning, press one button, and launch a personal aircraft into the sky. That is not a road trip anymore. That is something else entirely. But that vehicle still requires a field to launch from. The next one requires nothing except a destination. The EHang EH216S is a fully autonomous passenger drone. You sit inside, pick your destination on a touchscreen, and the aircraft flies you there on its own. No controls inside the cabin. No stick, no wheel, no pedals. Just a screen, a seat, and the sky. Here is what makes this genuinely historic. In October 2023, China's Civil Aviation Administration gave this aircraft an official type certificate, the highest level of safety approval any aircraft can receive. Government inspectors examined every part of the design, tested it under tough conditions, and officially confirmed it was safe to carry real passengers. That made the EH216S the first fully autonomous passenger-carrying drone in history to receive that level of certification anywhere in the world. Not a concept, not a prototype, a certified aircraft. It features 8 folding arms with 16 independent rotors, carries 2 passengers, and is monitored by a ground control center during every flight. The operators on the ground can step in if anything unusual happens. But in most cases, the AI handles everything from takeoff to landing without any human input at all. Now, if sitting in a pilotless aircraft still feels a little too futuristic for your comfort, the next vehicle takes a completely opposite approach. One that is all muscle, all human, and absolutely insane. The Gravity Industries jetsuit, built by British inventor Richard Browning, uses 2 jet engines on each arm and 1 on the back. Together they produce over 1,000 horsepower. more than most sports cars. The pilot controls direction by moving their arms and shifting body weight. Lean forward, you go forward. Shift left, you go left. It can reach speeds of up to 53 miles per hour and climb to nearly 12,000 feet. The honest part though, the jet suit burns fuel fast. You get about 10 minutes of flight time per tank, but military and rescue teams are already testing it for real-world use. Imagine a paramedic flying over gridlock traffic to reach an accident scene in minutes. And every minute of flight time in that suit generates data. Data about how humans interact with personal flight. Data that shapes safer, longer-lasting versions of this technology. Think of it like the Wright brothers at Kitty Hawk. 12 seconds in the air, but those 12 seconds changed everything. If the jet suit is built for thrill seekers, the next vehicle is built for everyone else. The Jetson 1 is a single-seat flying vehicle that weighs only 190 pounds, less than most motorcycles. It runs on 8 electric motors, hits speeds of 63 miles per hour, and in many places, you do not need a pilot's license to fly it. The secret is the onboard flight computer. It handles all the complex stabilization automatically. If you let go of the joystick mid-flight, the aircraft hovers and waits for your next input. It essentially babysits you while you fly. Early owners have described it as one of the most exciting experiences of their lives. And the price, while not cheap today, is falling as production scales up. We have seen this story before with electric cars, smartphones, and personal computers. The Jetson 1 is at the early adopter stage right now. Give it 5 years and it will look very different on the market. Now we scale up from personal flyers to something much bigger. The Autoflight Prosperity is a large electric vertical takeoff and landing aircraft designed to carry multiple passengers on routes between cities or across metro areas. And it recently set a world record for the longest flight ever completed by an electric aircraft of its kind, covering 155 miles on a single charge. That is roughly the distance from Washington, D.C. to New York City, flown without burning a single drop of fuel. For passengers, this works like an air taxi. You book a ride, you get in, the aircraft flies you to your destination on its own. But what truly separates the Prosperity beyond that range number is its safety architecture. The engineers built in multiple protection layers that work independently of each other. If a critical component fails mid-flight, the onboard AI can deploy a ballistic parachute within a fraction of a second and float the entire aircraft down safely. If a parachute is not needed, but something still goes wrong, the system can perform a full emergency landing completely without human input. That level of built-in protection is precisely what will eventually convince regular commuters to trust an autonomous air taxi more than they trust the highway. Now let us talk about racing, because racing has always been where the technology that ends up in your car gets tested first. The Airspeeder Mark III was built specifically for the world's first flying car racing series. Remote pilots sit in locations wearing virtual reality headsets and race these aircraft through three-dimensional aerial courses at speeds of up to 186 miles per hour. Think about that. Formula One cars race at similar speeds on flat tracks, surrounded by walls and barriers. These vehicles race through open airspace in 3 full dimensions. Every major racing competition in history has been an engineering laboratory. NASCAR taught us about tire performance and engine reliability under stress. Formula One gave us carbon fiber and advanced aerodynamics. Those technologies eventually found their way into the cars regular people drive to work. The Airspeeder series is doing the exact same thing for flying vehicles. The collision avoidance software, sensor arrays, lightweight materials, and battery management systems are all being pushed to their absolute limits in real races. Every close call, every record lap, every mechanical failure generates engineering insight that makes the next generation of civilian aircraft safer and smarter. The Pivotal Helix takes a different angle entirely. This American-made ultralight flying vehicle weighs just 254 pounds. Under U.S. federal regulations for ultralight aircraft, you do not need a pilot license to fly it. The company says you can learn to operate it safely in less than an hour. And that is not marketing. The flight control software handles takeoff, landing, and stabilization automatically. You focus on direction. The computer focuses on everything else. Meanwhile, across the Pacific, Chinese cities already have fleets of autonomous drones delivering food, medicine, and packages to automated neighborhood kiosks at massive scale. Consumers walk to a nearby collection point and pick up their order without a single human delivery driver involved. That delivery network is not just a convenience service, it is a training ground. Managing thousands of small drones flying through city airspace every single day builds the coordination software, the traffic management systems, and the real-world data needed to eventually guide hundreds of personal flying vehicles through those same skies safely. The delivery drones are the practice run, and that practice run is already happening at scale. And then there is the machine at the top of this list. The one that does not just change how you travel across town, it changes where you choose to live. The XTI Trifan 600 is a full-size hybrid aircraft designed to replace short and medium-distance regional travel entirely. It uses 3 ducted fans, large enclosed propellers. 2 sit inside the wings and rotate 90 degrees. At takeoff, they point straight up and lift the aircraft vertically off the ground like a helicopter. Once airborne, they rotate forward, and the aircraft transitions into high-speed horizontal flight like a conventional plane. This means the Trifan 600 takes off from a rooftop, a corporate parking lot, or a private property. No airport, no runway, no terminal lines or baggage carousels. Once in the air, it carries 6 passengers at a cruise speed of 380 miles per hour, reaches 30,000 feet, and has a range of nearly 1,500 miles. A road trip that normally eats 5 to 6 hours of your life in heavy traffic becomes a 90-minute door-to-door flight. That is not just a faster way to travel. It changes where people choose to live, where businesses choose to open, and how entire regional economies connect. 8 flying vehicles, all real, all tested, all pointing at the same destination, a world where the sky is as routinely traveled as the highway below it. But while engineers were figuring out how to make the sky accessible, a completely different group of engineers was quietly solving a problem that affects every single person who has ever stopped at a gas station. And the number they landed on is so far beyond what anyone expected that it made an entire industry stop and stare. In April 2026, at the Beijing Auto Show, a Chinese company called Geely walked onto the stage and showed a number on a giant screen that left engineers across 3 continents genuinely silent. 106 miles per gallon. Not in a lab test with ideal conditions. Not on a closed track. On a public road in Hainan province, in a mid-size family sedan. And Guinness World Records had official adjudicators on site for the entire test to verify and certify every single measurement. Official, verified, stamped. To understand why that number is so staggering, you need to know one simple thing about how engines work. When gasoline burns inside an engine, only a portion of that energy actually moves the car forward. The rest escapes as heat through the exhaust pipe or gets absorbed into the engine metal itself. The percentage that actually becomes forward motion is what engineers call thermal efficiency. A regular gasoline engine in the car sitting in most driveways right now converts about 30 to 35% of its fuel into motion. Everything else is wasted heat. Toyota, the company that invented the modern hybrid and has spent 30 years refining it, maxed out their most advanced engine at 41% thermal efficiency. For years, according to industry benchmarking data, that was considered the gold standard, the number everyone else aimed for, and nobody matched. Geely's new engine, the B15, hits 48.41%. Here is the comparison that really puts it in perspective. The engines inside Formula One race cars, the most sophisticated internal combustion engines ever built, the ones that cost millions of dollars each and are rebuilt after every single race, operate at around 50% thermal efficiency. Geely built an engine for a family sedan that is within touching distance of Formula One performance, and they are putting it in a car that costs less than $10,000. When that engine is paired with a 308 horsepower electric motor and an AI energy management system that constantly decides in real time whether to use the engine, the battery, or both, the result is 106 miles per gallon on a public road in a car a regular family can actually buy. In 2024, Toyota drove a Prius from Los Angeles all the way to New York City to showcase peak fuel efficiency. That famous road trip averaged 92.9 miles per gallon, which was considered a landmark achievement for the hybrid world. Geely's system beats it by more than 12%, in a vehicle that costs a fraction of the price. And this is not one isolated breakthrough. BYD, the company that recently passed Tesla to become the world's top-selling electric vehicle manufacturer, according to global sales data, launched its fifth-generation hybrid system with 46.06% thermal efficiency. Their top model travels over 1,300 miles on a single tank combined with a full battery charge. That is the driving distance from Miami all the way to Boston without making a single fuel stop. Other major Chinese brands, including Chang'an, Seres, GAC, Chery, and Great Wall, have all launched similar ultra-efficient powertrains within the last 18 months. A number that was cutting-edge laboratory performance just a few years ago is becoming a baseline expectation across the market. Meanwhile, traditional engines made in Detroit by Ford, General Motors, and Stellantis are mostly still operating between 30 and 35% thermal efficiency. That gap does not close quickly. Redesigning an engine platform, retooling a factory, retraining engineers, and getting a new product into production takes years. The window between what the most efficient hybrids are doing and what conventional combustion engines are doing is growing, and it is growing fast. What makes this even more interesting is the way the technology spreads beyond Chinese borders. Geely does not only sell cars under its own name, it owns Volvo, it owns Polestar, it runs a major luxury joint venture with Mercedes-Benz. It actively licenses its powertrains to other brands. That means these ultra-efficient engines will start appearing inside European and American vehicles within the next few years, whether traditional legacy brands engineer their own versions or not. Now, step back and look at everything in this video as a single picture. 8 flying vehicles already real, already tested, already certified, or in production. And an engine that officially rewrote the records for what a car can do on a single gallon of fuel. These are not two separate stories. They are part of the same shift. The walls between what counts as advanced technology and what regular people can actually afford and use are coming down. Think about what happened with smartphones. In 2000, a mobile phone made calls. By 2007, it replaced your camera, your map, your music player, and your internet browser. Industries that had existed for decades could not keep up. Transportation is doing the same thing right now. The sky is no longer just for birds and billion-dollar airlines. The gas station is no longer the center of your transportation life. And the companies leading that transformation are not always the names you grew up hearing. Some of them are writing entirely new names on the map. So here is the question worth sitting with. Between a flying vehicle that lifts off from your own driveway and an engine that carries you over 1,000 miles on one tank, which one changes your daily life more? Drop your answer in the comments. And if this video showed you something you did not expect, hit like and subscribe, because the next chapter of this story is already being written.